We think that every building in the urban landscape could eventually be a power source, where you get to the point of, we need more power, let's build another building. That was some of the premise that we approached on the next building I'm going to show you, which is the Pearl River Tower in Guangzhou, China. This building is a 72-story mixed-use building, primarily office, and we took the approach here that we wanted to design a tower that was zero energy, that would create as much power at the site as it used. We weren't ultimately successful in that because in China, the grid is not set up yet to be able to contribute power from buildings to the grid and then pull that power back out when needed to be. So it's at the point where it's about 50 to 60% to that way. But obviously orientation is a major issue here, and various systems throughout the building are also very important, not least of which is the exterior wall, the elevating systems, the orientation of the building, how the tenants use the space, how we use light from the sun to reduce the amount of artificial light that has to be produced in the building, and what we can do to reduce the amount of power that we're using within the mechanical systems themselves. The building here is formed by the idea of harvesting the wind that's moving from the south, in this case, hitting the building full force, and we've shaped the building to funnel that or harvest that wind force through 4 openings in the building to create a higher velocity of wind to generate wind speed for driving turbines in this building. Now that sounds like an idea that could work. Here we generate approximately 5 to 10% of the power of the building itself by the turbines. But we do, by funneling the wind, increase the usability of the turbines by approximately 50% of the time. Without that funneling, these turbines would not be in operation for half the time that they currently would be in operation now, funneling the wind. So that's one of the things we mean by form follows performance. This building is also, here's the shaping of the fuselage, so to speak, to create this opening for the turbines. But we also are using the shape of the building to harvest the sun, and we're putting photovoltaics that are integrated within the exterior wall on the sunny portions of the building facing the south. We also are using radiant cooling systems with chilled beams and displacement ventilation, ventilation from the underfloor to make the space very comfortable within a low energy cost. We're not driving a lot of it, we're not moving a lot of air, which is an expensive and energy prohibitive means of cooling spaces, which most buildings in the world now do. Our goal is to get to positive energy, and it takes a lot of small steps to get there.